I'm so sorry. Sorry for the confusion. Actually, I can't hear you right now. I think I can whenever I put on my headphones.
Bitluni is now live, streaming less than
Here we go.
Casual making.
Let me connect the headphones.
Greetings from Boulder.
Hey Peter. Hey Alteris, Kasper.
Here we go. First time I was here before you.
Here. Wait. Still needs to switch to headphones. Here we go. My hair is terrible right now. I'm running hot. I had just some mee noodles quickly. I totally messed up today. Scheduling the stream for 7 o'clock. That was wishful thinking because I lately get tired early. You probably noticed on the Friday stream. With a miss that I think we only did 2 hours or something. Is this better? The light is weird today. I don't have a mount for light directly in front of me. It looks it looks sus. Hey Sonic. Hey Johnny. Random stuff. Oh, I missed all the chat. So sorry. Yeah, now I rushed eating. The noodles are not chewed at all. I have just a bunch of noodles and kluski. I had noodles with kluski with meat filling and pepper sauce. So weird combination for dinner. Just because I was starving. I was watching the movie Rental Family. It's a quite good movie. Yeah, didn't break anything. Yes. Yeah, Sonic. Yeah, no energy drinks here. We have Bitzel because diet was out. So, temperatures in here, manageable, 22 degrees. It's even like quite cold lately during the nights. It's like, we had 7 degrees recently. So not very, very great. But good for doing all the chores and managing stuff. We might be so what I did this week, I didn't finish 8 degrees C. Oh, Peter, even at this altitude, wow. So what I was doing is before the stream and before I watched the movie, I tried to adapt the high-speed USB stuff, and the implementation by WCH is a little bit messy. I can show you what. It's not like straightforward. Either I copy it and clean it up again manually, but looks weird. Alteris, yeah, it's cold. 38, yeah, we had quite hot days as well. Next week again, but this week we can actually work a little bit. Yeah. Hey, Jumbo. So that's that. Yeah, I also have done like a detailed project description for the NLnet funding. So whoever missed it before, the M.2 stuff that inspired me to apply for NLnet funding. So we don't need a sponsor for that. To basically develop like an open platform for basically PCI Express with bridges, possibly most probably PCI Express to USB bridges that have like common drivers that you don't need to install, or like any other implementation of PCI Express to whatever bus. That's basically about it. And what the goal of the project is, that in the end there will be just a template for anyone, like open source, a template for anyone to use, to basically make a dev board or whatever, which can sit in the M.2 M.2 slot, like the cluster here. So this was also a bridge, but this is like a PCI Express to serial bridge. So that would be an option. I'm a boy. No, it wasn't a year. It did. You have been here, like. I'm Europe. You had returned. Okay. What? Oh, really? Yeah. So when I started my project, huh? No, that was quite a like the Ultra cluster, quite a long time. Welcome back. Wasn't we're still not finished. You might have seen or watched a video that I uploaded for that. So hardware, we have like one first iteration of the Ultra cluster with 8,000 cores, and now optimizing it for high speed. That's a requirement, right? So yeah, that's basically what I'm doing right now. As it seems, I get my next chunk of cash from Altium. I will only get in September, like 5th of September. Put in the invoice. It takes quite a long time. I don't know why. I mean, I don't complain because it took me also a while to release any video on that project. So I'm not complaining here. I'm really happy that it worked out as it worked out right now. Let me check for what the stats are. I think it's 800k views so far. No, it's not. 742. Yeah, I wished it was going a little better. Here it is. Here are the stats. 18 days, 400. That's what it did. And you know, I mean, so much work. You know what if you don't have any sponsorships, you know what you earn if you have like a video. If you have like here, these are the honest stats: 1.1 million views, revenue 1.9k. So you would need like 1 million view video per month to earn enough to come by in Germany monthly. So that's not a project that takes. Yeah. That's a bummer. I don't know how to update like or make it improve my RPM, revenue per million, or what is it? Yeah, basically, or CPM, cost per, I don't know how you call all this stuff. Release schedule. Yeah, how do you release? I need like to get 1 million views on anything. I need to have something, release something impactful. There is nothing impactful that you can accomplish within 1 month, including editing and everything and waiting for PCBs. I mean, you can schedule like the project for the next month and so on and so on. Of course, that's possible, but I don't know. I'm too old to be fast. Anyways, I feel grateful that I have the possibility with like sponsorships to basically make a living despite the low income of YouTube. LED tileable panel again, meter by meter. Again, I mean, LED wall 2 was 40 centimeters across. So, no, LED wall 3 was tileable. But like oversized PCBs, yeah, very expensive. Go big or yeah, I have some. I mean, I have like little projects that I could do that are quickly made, and I have the grand unified theory. You mean like M theory or what? What? LED work. You can basically, yeah, you could probably plaster. There are possibly cars that are completely plastered with LEDs. Hey, Tommy. So, yeah, I have a few ideas. I mean, we have like two other projects basically. Oh, congratulations, Caspar. Vinyl wrap but pink LEDs. That's good. Will you not work on your disk anymore? I will, Natsu. That's what we are doing here. I didn't want to jump right in here in the code. We still have like we are porting. If you like, I'm rewriting the my working CDC code to basically the high speed, fast, full speed to high speed. It's completely different. But we are chit-chatting first. So, shalom, the Shipu. Where was I? Yeah, quick projects. We have like two. The one, I mean, I already announced in that video the little 13 cent MCU USB to video device. I don't know where it is. I need to find it first before I can make a video on that. I found the PCBs though. Here. Here, these are the PCBs. I found those, but not the device. I need to find that for B-roll. So basically, I have enough footage for that. bitluni searching simulator. you should totally make a game on Steam for that, like total chaos with components, and then you search for a certain thing while stream is flaming. Oh, that would be amazing. I mean, you can probably do it with AI nowadays. I don't know how good is AI with generating 3D Zectronics. Let me check. Zectronics. Ah, all right. Next project. So basically, the open PCI Express platform for like PC. One part. I mean, I can share with you, since everything is open, including the documentation. It's not finalized yet, so I might not share all specific. Let me check if I can share. Yeah, because that's like public funding, but I can. I have an appointment tomorrow to discuss this, basically the milestones of that project, and I have here. So we have hardware design, which is basically what we. Okay, this is like adaptation of we have some templates for PCI Express M plus B design, and hey, Holy Flame. Hi TT, hey. To plug it into your streaming PC for good while stream ended. What? Yeah. We were crushing stuff. Okay. So basically, this is identifying the interface ICs that are available right now, but there are also a few projects based off FPGAs. I think Cologne. I don't know, what is the Cologne FPGA? They had like PCI Express stack, or they were developing something. I don't know. I need to check that, and then basically what we need to do. I can maybe draw. Let me draw. So since today we are professional, we will do black, white on black. So what we want in the end is we have too thick. We have let's say an M.2. We all have like with two gaps, because there are like two versions, dark mode, and then we have this is like M.2 form factor, and then for the M.2, let's say we have like two-sided, two sides, but what will happen here? We have like two lines of PCI Express, the plus and minus, a differential pair. We're only using one and one clock line, and then we have like a section of that. This will be a template, a section which has basically figured out the PCI Express bridge to whatever interface you have there, or in this direction, and then let's say also power. Let's say we have so power safety is a thing, because if you offer let's say a perf board that has an RP microcontroller on there, RP, so this will be one part of that. This is basically like a template, and this basically this part here can be interchanged with any other interface, but we have like a standard or a design guide where to place the traces, and basically also the power figured out, everything figured out. So everyone who wants to do a project with M.2 will be able to take this open source, which is, I don't know how you draw this open source logo. Like a cog. This I don't know, open source. Yeah, basically, and you can solder even LEDs to that. And one of the requirements is to have like quite safe power. So if you short things, you won't like mess with your PC main board. So basically there needs to be some power things, and I hope, I mean, what is the what I don't think these are the final tasks. Power regulation 8 hours. 2 of those hours will be discussing it with you guys. I hope you're on board. Yeah, so basically we will have some proper power regulations and so on, and then the design, the templates. I mean, the length of the is straightforward. It's only like, yeah, basically PCI just handling anything that's like a dev board, but for your PC, like for your PC slot. Same with PCI Express cards, like PC cards times 1. Oh no, that's almost got it wrong. I think times 1 is the first part is longer than the second one, like that. And here we will have like assemble a few, like here is your section with the bridge. No, bridge will be here, because I think PCI Express lanes are here. There, this part is power, so this is basically power. Power handling with fuses and so on, and then you have your bridge here, which and maybe MCU here, like everything standardized. MCU, if you need an MCU, might be that you will have just a parallel bridge and then everything here. So there's a possibility to, depending on what's possible there. And also, if you want to program the MCU, it needs to be, basically, you need to be able to like have something to trigger reset or whatever externally. So some of the requirements. But what we can do here is we can do our classic R to R resistor ladders and make a VGA card, for example. That's one of the we just take one of our old designs, put it on there. So basically you can make your own hardware. Retro computing, yeah, and basically we have here example projects. Oh yeah, analog coprocessor design would be a thing, but it's too expensive timely. I don't have the budget for that. The time budget, I had like 16 hours for. I'm just discussing standard of VGA that allowed audio. I mean DVI more or less does that a rabbit hole. Yeah, the DVI, I think no. DVI was also without audio. Anyways, but you can combine it on that card. So we have a sound card design. It's quite straightforward. I just want an example that works. And we can also put computing clusters on that. So we can just put it full of those MCU chips. And you have an interface, you put it in and you play around with that. Yeah, analog ray tracer, but that's not in the time budget. Basically, I'm for my grant from LNet doesn't fit. So basically, analog coprocessor was the precursor of the analog ray tracing card, but this is not possible with the time. So we are restricted basically to anything that projects that I done before to adapt them as example for those cards, and the goal would be to have that released, like everything open released, and then I will probably make a run at China, so people who don't want like to assemble it themselves, they can order it. That would be one goal of this project as well. But basically hardware production, there is like, I mean, for that that's only like the design part, PCB design, and then we have software hardware production. It's basically we have some manual assembly, but then most of the things would be assembled directly in China, the second iteration at least. So we don't have a lot of work here, because apparently man hours are more expensive than than the robots in the factories in China. Yeah, software interfaces. So basically there will be platform IO, Arduino library of course, and MicroPython as well. I never did that before, but shouldn't be that hard. Anyways, that's the project I was talking about before. But now, back to the chopper. And with chopper, I mean thunderscope. No, I'm not familiar with that. What is thunderscope? Thunderscope crowd supply. Oh, all right. Oh, this is an oscilloscope as a PCI Express card. It was funded 24. Was it shipped already? Yeah, but so for the funding, the requirement is it's not a regular man hour. So I would take $100 per man hour usually nowadays, and what gets funded is like 50. So that's basically the limit, more or less nowadays. At least that's what I had to calculate with, unfortunately. So it's more or less it's a service to the community. And there will be of course video. I mean that it will be short and fun projects to make a VGA card, and we can put like the sound interface on the VGA card as well, so you have a combination of both. Or we can make a sound card with MIDI interface as well. The new MIDI interface that it doesn't need like this wide DIN connector, just a 3.5 millimeter jack connector, think it was like 3 joystick. Yes, they had MIDI and joystick. That's that. I had one. I bought one. I bought it. That is interesting. I think I even paid 40 Deutsche Mark for the MIDI cable because the card for the joystick was cheap, but the cable was like paid for the cable because I had a MIDI keyboard and I was curious, but I don't think even that I had any software that would be able to talk to the MIDI port. I'm not sure if I used it with the keyboard like as an output in the end for playing games. It was weird. MPU 301. Rosengarten. Okay, so what is MIDI 3.5? Yeah, that's, here we go, the new standard. Oh, why the hate for? That's the new interface. I think it's only like 5 years old now, is it? Ah, was this MS-DOS? Yeah, that was. Wait. Yeah, no, I was when at that time the only thing I knew was MS-DOS 5.50. That was where I started. Okay, let's check MPU 401. Yeah, the Yamaha, was it? UART mode, okay. Oh, Roland, okay. Roland, okay, that's the general MIDI. DOS forum. Okay, that's German. Anyways, yeah, let's figure out the rewrite. I wasn't finished. So this is the old implementation. Do I have the new one? So it's a little bit messy what I found in the high-speed implementation. Basically, there is like all sorts of stuff that is a little bit confusing, especially since you have basically like when they you can write. I think high speed only matters. I'm not sure. Here they are using the bigger packet size, like 1024 bytes, which is obviously great because you save a lot on the overhead if you compare to the 64 bytes. But there is like where is it, like weird stuff going on in the code here. So when I checked out the code, it is like basically endpoint 3 and 2 and endpoint 3 Rx is connecting to endpoint 3 TX buffer, and Rx isn't even defined. I don't know if it's like a bidirectional endpoint 3. So I'm a little bit confused. The same thing with endpoint 2. Either it's TX buffer or UART TX buffer. So probably this is they try to connect directly what's coming in from the external UART pin and directly forwarding it to the USB as a buffer or something. So weird stuff going on there. And like, yes, it is. And there is like stuff that the scripter, yeah, here you have USB-D config high speed descriptor length, for the full speed descriptor length, and then for the high speed descriptor length you have the full speed descriptor length. The only reason why it works is because both are the same, because both are the same size. So I compared the descriptors, they are similar, so there is no difference in high speed. I think the only difference how high speed and full speed is determined is like on plugging in which line is pulled low, high, or like constellation of that. As far as I remember, I don't know, maybe someone can clarify that. USB speed. Well, maybe let's go Gemini and ask it. Shall we ask it here? Chirping might be. How does USB detect if there is like a high-speed device or full-speed device connected?
USB uses passive pull-up resistors on the D+ and D- data lines to detect a connection and its initial speed class, full speed, 12 megabits per second. The device pulls the D+ line up to 3.3 volts with a 1.5 kilo ohms resistor. Low speed, 1.5 megabits per second. The device pulls the D line up to 3.3 volts with a 1.5 kilo ohms resistor. High speed, 480 megabits per second devices initially connect as full speed devices. Once connected, the host and device perform a dynamic handshake called chirping. 1. The device sends a series of high-speed K-state current pulses, chirps down the line. 2. The host detects these chirps and responds with alternating K and J chirps. 3. Upon receiving the host's response, both sides disconnect their pull-up resistors, enable 45 ohms termination resistors, and switch to high-speed signaling mode.
Alright, you were right with the chirping. So for high speed there is apparently different. So actually that's that. Okay, let's ask it about CDC. Is CDC device class specified for high speed?
Yes, it is. The USB Communications Device Class, CDC specification, supports high-speed, 480 megabits per second operation using 512-byte bulk endpoint max packet sizes instead of full-speed 64-byte limit.
But it says it's 512, and this is nice hint though. It says 512. And I don't know if I changed it or yeah. Oh no, here, high speed. Oh, okay. So it's defined here, 512. I think we messed with that before. Can't really remember. It was a long time ago that we did that. So actually, it's specified as 512 bytes. The maximum ISO size is 1024. Interesting. Full speed ISO size seems to be also 123. Weird. All right. So let me fix up. So what we have to do right now is we have to let me put that simulate CDC so I have a comparison. What I already updated is, okay, I changed stuff here. Wait, this is the CDC high speed. So I already copied that part because we have like the high speed size, except for endpoint 0, which is only regular 64 bytes. Yeah. Then we have, of course, there is the high-speed RQ handler, which isn't implemented yet. We have like only the full speed. The RCC init, I think we had to change the divider because we are using, I'm not sure if it's changed here already. Unfortunately, too long ago that we played around with that. We might need to change that because we are using a 16 megabit crystal. Okay, change for crystal. Okay, oh, maybe I should do to do. I think, yeah, do we? Okay, that's fixed. Then I copied that part, so high-speed setup, except I use RX for RxDM. So to be clear, I'm using RX buffers and TX buffers like correctly. So what we had set up here, let me check. No, is this the setup? Sorry if it's, I'm scrolling, jumping back and forth. Okay, so in this setup, they're only using one buffer. There's no TX or endpoint 0, 1, 2, 3. They just use like 4 buffers, no specific endpoint buffers here. Yes, they are. They are here aligned for 4 bytes. So I hope that is correct here. I'm not sure. Interrupt. It's alright. Not sure if there is something missing. Anyways, we have a device in it. I just copied that because that's completely like only flags and registers, except for endpoint init. And this is, wait, device endpoint. We have device endpoint init, yes, here. So this probably one that, yeah, we had that, that's that, okay. And then data up, this is basically a receiving data, and device data upload helper interface, okay, upload data up, pbuffer, okay, that's sending data. Endpoint, this is, yeah, this is basically the implementation, the lows, the full speed implementation, and what I'm checking is against the code, the high speed implementation here. It's way more complicated. So DMA config, so it has, okay, it supports more endpoints, so it's basically, then we have endpoint TX. It has a lot more going on because it uses TX endpoint Oh, there is the mem copy. Okay, so we have DMA load. Oh wow, and double buffer, endpoint buffer is. Let me check that. Hey Bombo. So it's a little bit more complicated. I think I will just take this implementation because I don't know, there's like nothing specific. The mem copy, I'm confused about that. Yeah, it's the same. I'm also not understanding it, especially because here there is no double buffer implementation. I'm switching to high speed USB high speed implementation for the CDC of my ultra cluster. We had only full speed so far. Okay, so buffer load. Endpoint. TXRX. Oh wow. You know what? I will just take this implementation. I don't really like it. We can run it through Gemini and see. Okay, let's see. Yeah, it is sometimes. Okay, here is a cleaned up, refactored version of your function to improve readability, mainability. Use early guard clauses to eliminate deep. Yeah, that's what's confusing here. Return one. Okay, that's cool. That's way more readable. I'm wondering if this works better. Let me check that. We don't have many nested. There is the mem copy and this single buffer mode. You know what? I will just copy that because I like the cleaner version much more than this super nested mess here. Yeah, we have like, if you compare that, we did the early exit, it's always return one, return one, return one. So basically, that's what they are checking early. All right, so let's take the cleaned up version. It's way better readable. And we will put it here. Except something's missing up there. High speed device. Here we go. Ah! Shit. High speed size. Okay. Now we're in trouble here. Because that's fast speed data end up. We don't need that anymore. Yeah, I will totally use that instead. But we need to, okay, this device in it, high speeds. Oh, wait a second. And this is this part. Okay. Wasn't that in descriptors? High speed size. Where's that defined? Okay, now I need to chase for the code here. So oh, that's in the, that should be in the descriptor. I don't know why it's complaining. It's probably because I didn't compile it first. Okay, now it's gone. Endpoint number. Oh, interesting. Can find that part. Where is it? $16. Huh? Should be defined in there. Open. Don't I have that? Apparently. Oh, wait a second. This is, yeah. We don't have that. We have only fast speed here. Yeah, I need to copy that file here as well. That was missing. That's okay. I bet. Oh, where's the name? X underscore. Okay, that was missing. Yeah, there is the descriptor, the UART age. This needs to go. Same like here, string is still use string as well. Okay. Well, maybe you know what? I will leave it there. Just like we need to compare what I removed from that. Not much, so. Oi oi oi. It looks like, oh yeah. TX buffer. So way more going on in the high-speed device. Alright, we don't need that anymore. Where is it? High-speed, the descriptor include is used elsewhere. Alright, so now everything should be defined. We have data up. Now we have the full speed, which will be the high speed handler. The handler is this part, which is the most crucial for us, because that's basically the remainder of the implementation. Everything else is, I think, covered. And I need to compare this with the handler that's used here. Oh, this is so messy. It's huge. Okay, I will try to simplify that. Okay, we have transfer token mask. High speed setup require. That's basically that. Requirement type. That's similar. We will just change everything to HS requirement code. Okay, we have that as well. That's completely similar so far. High speed. It's a good practice to also check the descriptor length. Okay. Full speed device address. Okay, this is different. Oh yeah. This is oops. High speed device, TX length, and we have TX control, USB highs. Okay, this is interesting. This is different. I'll just compare line by line because our implementation is way shorter. Then we have high speed device address, which is also not this. It's not covered here. And this is the high speed naming, interestingly different. Then we have this part missing here. Okay, I think, oh, there's this high speed descriptor. So what we are doing here, this is basically set up. So we are transferring the descriptor. Now endpoint is interrupt. Okay. We can basically copy that part because that's completely the same, except it's endpoint 1. We didn't have the right chip. I needed to reorder a different chip. We start with the 303 and now we have the 307 and needed to botch that, and basically I didn't know that there is a difference. I learned my lesson. So endpoint 1 data in interrupt. Why do we have Oh, interesting. There might be even an error here. It says endpoint 2, but this is wrong. It should be endpoint 1. We have also endpoint 1 here. So this is weird. Why is it using endpoint 2? Endpoint 2, endpoint 2. That looks weird. Now I'm confused. What is the right thing? Yeah. So I guess I will use we can this is terrible. Like how do you know which one is correct here? If we compare that. Okay. You know what? Let's ask our knowledgeable friend. I found 2 implementations of CDC with different interrupt endpoints. Endpoint 2. Oh, you think there is a difference? Let me check that. Okay, let's see what it says. Huh? Let me check that. We have the descriptor here. Configuration descriptor, interface CDC, interrupt load endpoint descriptor, interface 1, data interface endpoint descriptor, endpoint 2. Interrupt is endpoint 1. Oh wait, this is high speed. Okay, this is full speed, this is high speed. High speed is endpoint. Where's the interrupt? Interrupt. Endpoint 3. Fast speed. What? No! Oh! Now here it is. Oh wait, there was like a thing with receive and transmit. If the first bit is set, oh, that's so weird. This is like all over the place. Yeah, what, Gemini, what do you say? Huh? Okay. Damn it. Okay, let's use the original code here. This is so weird. Oh man. Yeah. Alright. Weird. U-word. Okay, we don't need U-word. This is not what we do. And also this is our yes, 307 is the model number. I think 317 is similar. CDC TX complete, interesting. That was our completion. Okay. Next point is we have high speed UIS. What is UIS token out? Okay, end mask, endpoint. This is sim. Oh, there is one difference. They take the length from here in between. I don't know why. It has length here. High speed, okay. Now we have setup request type standard, okay. Setup request line coding. Okay, line coding is completely not interesting. And this is our high speed buffer. This is our callback, so that's easier. Otherwise we have no else case. Oh, what is this? Oh yeah, if setup request length is 0, then high speed device, high speed TX length talk. I think I need to replace that part. Yeah, that's it's a little bit longer. Okay, that is covered. We are working our way through. You can see here we have several screens to rework, but it's not it should, I hope it works right away, otherwise we can still debug. So we will find out if it we can set breakpoints in the interrupt and debug it, fortunately. UI's token out rep. This is this code. High speed. Oh. High speed. This is wrong. Talk data 1 is a little bit more. And then what it does is basic. Oh, interesting. We skip all that crap code and do basically that. which is whoop, Rx length. Oh, UART TX buffer. That's not that. We don't do UART TX buffer. Hey Foo! Hello, welcome, welcome. So what we do, we're not using that, we're using that instead. So here it is. Whoop! Because that's endpoint 2. So replaced that. Next token. What is this? Determine if downlink needs to be paused. Oh, we have new stuff here going on. So what? Basil, what's going on? What? Level 4. The film. No. Level 4 is the highest level. Like, this is the lowest level is 0 because it's easier to count from there. You don't add. I initially started like to have level 0 to be first. Yeah, foo. Okay, we have here some extra code. So that's data. We have USB high speed device length, that's the UART. Interesting, high speed. Oh, it's double buffering. Oh no. Oh no, it's double buffering. Oh no. Oh shit. Yeah, we need to optimize that later. I think even we had an implementation for that. We need like the new TX buffer, the double buffer. Ah, yeah. Okay. So they use double buffering. I don't care about that. We don't change that yet. I will comment on that. So what we are doing here, original code swaps buffers here, blah. I mean rather here. Okay, let's put it to do so we can find it. Headstream, so much camera gone to waste. What? What? What's I don't understand your text. Okay, so determine the downlink needs to be paused. Paused is in the case remain number. Okay, so basically they are pausing it. Neck action. Oh, you want to see my neck? Wait. More of the seat here. But the seat is. I don't know if I can put the camera lower, then you will see my screen. So now you see my neck. All right. Slouching. Okay, I will. I'm tired. Pause is needed. Use that code. Yeah. I try to get off the drugs. I had so when I went, I mean you saw that last Friday stream. That was the one of the last cokes that I drank. In France, you get for $6, you get 12 cokes, more or less. And I thought, I'm on holiday. I will get some. And in the end, I had 5 of those crates of 12 each, which is 60 cokes in 12 days. That's a lot, or 10. I had quite a lot of Yeah, now I'm back from holiday, so I need to be. I sleep well. No, I don't. I actually woke up in the middle of the night, but yeah, I don't know. Don't feel restless. Yeah. That much in water. Yeah. Usually I take like lemonade, sugar-free lemonade. Yeah, water. A bottle of water. Do I have a bottle of water here? Nope. Okay, so we basically analyzed this code, double buffering. Here's some error flag. Does it do that? Yes. No, break. It doesn't do errors. It just breaks. Yeah. $1.5 liters of cola. Oh, foo! With sugar? How do your teeth look like? They're like sugary drinks, not only like with the phosphoric acid in Coke. That's bad already for the teeth, and then sugar on top of that. Not the real one. I can't drink the real one anymore. I really can't. It's not like, I mean, if you like sugary cola, that's alright. I also sometimes like sugary booster. But I'm so used to Coke Zero and so forth that I can't drink sugary drinks except for like juice or whatever in the morning, one glass of juice and stuff like that. But I couldn't like, if I'm thirsty, I can't drink sugary drinks. Oh, Basil. They want to save on the taxes. Yeah, my negative calories. Yeah, I try to get more calories elsewhere. So, I mean, currently I'm looking fine and I'm not very thin. You can still probably feel some ribs, but yeah, I don't feel like as bad as thin as before. Yeah, sugar taxes are coming to Germany probably as well. at some point. I don't know. There aren't any yet, but they are discussed already. So sugary drinks might get some taxes. Yeah, Basil, I heard that basically obesity in UK is a quite serious topic. It's UK was like the top one country in Europe that yeah with children. I think children obesity was the issue, not like grown-ups. So probably that's why the governments at some point decided to tax sugars. I don't know. Anyways, more interesting than politics is this endpoint here. Sounds about yeah. The only reason that why I'm not obese is because I'm ADHD, too lazy to or I forgot to eat. Sweeteners are basically worse. Who said that? I need show me the research that says that sweeteners are worse. It also depends on the sweeteners. I mean, stevia had a bad reputation, but I think that was only fake news in the end. I'm not sure. Okay, I need to wait. What is this? Setup Act. Token setup. Beer fountain is cover, yeah. Store all setup values. Yeah, that looks more or less the same. Oh, so without the caffeine, they got basically. What is this? Is else if. Oh wow, yeah, that's terrible here. Else if. High speed token setup. There is another switch. Okay, so we need to concentrate a little. Yeah, same with smoking most probably. If you don't have the drugs that excite your pulse, you're probably burning less calories in the end. Is that the case? Cancer risk? Really? Okay. Let's ask. Gemini will be now completely confused. Are sweeteners bad? Not in the same context, yes. I will mix them up. I will mix it up. FDA, there is, yeah, this is what I also heard. It's toxic average consuming moderate amounts of artificial and does not cause toxicity or cancer. Okay, long term. Trials show it can lead to modest short-term weight loss, better sugar control. Okay, WCH, the HO, advise against using non-sugar sweeteners as a primary tool for long-term weight loss or chronic disease prevention. The review suggests that long-term reliance on sweeteners doesn't magically melt away body fat and may be linked in observational studies to higher risks of type 2 diabetes and cardiovascular disease. Research debate whether this is because sweeteners directly cause harm or cause people who are already overweight or metabolically at risk tend to consume more diet product, a puzzle known as a reverse causation. Okay, so there is like no actual conclusion on that. Gut microbiome, so certain sweeteners can interact with gut bacteria. Impact varies greatly from person to person. Okay. Cognitive research continues to look into long consumptions that typically show correlation rather than definitive proof. Okay. Bottom line. They're not poison, not a health food either. Okay. However, relying on them heavily doesn't train you. Okay, blah blah blah. So basically, no matter what you do, everything that is fun is toxic. Yes, give me more booster. So what kind of sweetener do we have here? Zuckerfreie Limonade mit Süßungsmitteln. Where is it? Here. I can't even find the sweetener here. Säurungsmittel, Zitronensäure, Mandarinsaft, Grapefruitsaft, Limettensaft, Zitronensaft, Süßungsmittel. Natriumcyclamat. Okay. Natriumcyclamat. Oh, about it. Acceptable daily intake for it frequently appears blah blah blah. Sodium cyclamate is a heat-stable, high-potency artificial sweetener that is widely available, especially in Europe, often blended with saccharin to optimize taste and reduce production costs despite its historical ban. What? It's banned by the FDA. Study on rats with massive lifetime dose of cyclamides mixture reported an increased incidence of bladder tumors. While subsequent more extensive follow-up toxicology research failed to replicate these carcinogenic findings or link cyclamide directly to cancer in human or animals, the initial US ban has never been lifted. Interesting! This is a forbidden drink for the US viewers. Yeah. Basically, a war on who paid most. Who paid most? Which chemical company paid most? But this is a banned lemonade in the US. So how do we ban the errors from our code here? Why does that not do anything? What does it complain about? Problem? No. I don't know why it's. Why is it? What? What is happening here? There's a lot going on there. Yeah, Alexa removes. What, but why is this one? Expands to duplicate case 32. Oh, that's setup. Token out. Token in. Where is the setup token? Act set. Where is it? Huh? I don't see. Wait, maybe there are like duplicates. 10. That was 20 hex. 0. Ah. Token in is okay. Now it's. Let me check. Okay, so we have. Get the script. Wait. High speed setup request code. Was it that? I think I'm in the wrong case. Case token endpoint mask. I think I'm wrong or in the wrong. Simulate CTC switch. Oh, I'm wrong here. Huh? How did I get there? Huh? Wait a second. What the frick is this handler? Okay, so transfer, interrupt flag, transfer, interrupt flag. That's an interrupt flag. What? Okay, now this will be hard. Okay, let me check that. So this is, we need to revert this. Yeah, not doing that right now. Okay, a token setup, token out. And this is basically it's doing that else suspend. Why is it different? Why is the implementation different? Interrupt. Like we have completely different, here it is a token from transfer, and in the other implementation it's interrupt flag on its own, setup interrupt flag. That's weird. I need like to rewrite this whole part or what? Yeah, it looks like it. And then there is another else. Wait, this is like, wow, why is it so long? Interrupt flag, bus reset, suspend. Oh, this is hard. Yeah, we have all that crap in here. I really don't want. We can use this unless high speed descriptor. Okay, these are the descriptors. USB to do not support, blah blah. Okay, you know what? So be it. Let's take the setup, because that's crucial. And we need that high speed setup here. It's so big. There's suspend, that's basically that. This part, and let's take the setup token. Can we? No, we can't. Basically, this is where we want to go. Setup token, there. This needs to go. Bus reset, and this is where we place that part. And I hope that we don't have any crap in there. Wait, there is something. Config descriptor fast speed. Yeah, no, we don't need that. UART config. Get line coding. Okay, we have like a standard line coding here, which is defined. Ah, come on. Now here. Can you just find this freaking line here? Here. Okay. So get line coding. This is our. Oops. Line coding. Yeah. Basically buffer, high speed descriptor buffer. Okay, so oh, that's endpoint. Is it endpoint 0? Wait. Was it endpoint 0? Yes, endpoint 0. Okay. That's that. We will fix one by one, okay? I can see was okay, it needs an update apparently. There's more. High speed descriptor length. High, okay, load USB configuration by speed, and we have we have that, go to that. High speed, script of full speed. Or, you know what? Because we are using the same code. Oops. Okay, and there is the length. Oops. We probably don't have that. That's in descriptor age, USB descriptor, packet size. Whoop. Okay. We have that here. Why no? Unqualified. Yeah, okay. I see. They are annoyed by our implementation here. So let's do it basically reverse that. And this will be S, and descriptor age will be S. I combine both implementations here. This is still complaining or what? We have it here. What's going on? Let's try again. Nope. Oh, yeah. I think what we are missing is the predefinition here. Yeah, it's not predefined. Because it's defined in... Oh wait, and where is it defined though? And descriptor, okay. Descriptor C. Where is it predefined in CDC like the other one? Declaration. Okay. So we have config descriptor fs, this one here. No. Here still something's off. Line coding. Oh, CDC get set. What's going on? Why is it? What? Why is it complaining about that? So weird. Okay, yeah. No. Okay, I will ignore it for now. AI generated code. Descriptor quali. What is my quali descriptor? We don't have that. Qualify descriptor length. And never I'm seeing that for the first time. Yeah, that wasn't a part of the the other device. So let's check it out. Qualify qual descriptor. It's probably not the first one. We have also the BOS. What is the BOS is still there. USB2 do not support BOS descriptor. Okay. Qualified descriptor. What is the qualified descriptor? What is the qualified descriptor?
A qualified descriptor, or qualification descriptor, specifies rules, conditions, or properties that refine, filter, or fully identify an object or data set within a specific system. Its meaning depends on the context, databases, and data management. It is a data structure, like in SQL DBMS engines, that holds the criteria specified in a way.
I mean USB protocol.
In the USB 2.0 protocol, the device qualifier descriptor reports information about a high-speed capable device if it were operating at its other supported speed, e.g., how a high-speed device would configure if plugged into a full-speed port. It contains basic fields like USB version, device class, vendor/product IDs, and the number of possible configurations for that alternate speed mode.
Oh wow, okay, yeah, that's why we have some extra stuff there, peoples. So language descriptor. Now we will have the qualified descriptor, and we need that predefined also here. Quadescriptor here, extern. Oop. Okay, what's the next? What's qualified descriptor length? It's not specified. It's probably also specified in that device here. Where is it? We have it here. Where is the calculation of that? Oh, here, yeah. Qualified descriptor length is, yeah, it's basically byte 0 again. Okay, CDC descriptor H. Here we go. Hope we don't have as many errors, but it looks good. We are getting, there's like only a few more errors. We have something here. Full speed mode. FSO. Okay, full speed mode. what is it? OST of tab USB FS OST descriptor. Okay, so we have that things here. Let's clone that. Oh, high speed. Oh, we have that one, but not. Huh? Why is it? Hello. Okay. That one is missing. We only need to add it to from the descriptor table. Fast speed. Weird. Why do we have high speed but not fast speed in that thing? Okay, yeah, whatever. Why is it using also config descriptor high speed? Size off. Weird. Okay. This is another thing that's totally messy. Here's the qualified descriptor length. I thought I had added it. I didn't. Okay. And I added here qualify descriptor length. And there will be yet another one missing. Okay, we have USB high-speed test flag. The flag and the wait for the status to be uploaded before proceeding with actual operation. Test mode deal. Okay, so the test mode is basically for testing the high-speed USB. Test mode deal, high-speed test flag. Okay, let me check if that's global. So the flag and wait for the status to be uploaded before proceeding with the actual operation. Yeah, it's weird. Let me check that. If we're missing something. No, test flag. Okay, so let's find the test flag. Yeah, that's the test mode deal. It's basically like a, I don't know what the test mode actually is. Is this something like that's needed for USB fast speed implementation, or is it just for testing the speed? That's really weird. It sets a flag. It deals if the flag is set. It's in the test mode. Okay. Where is the flag set? Setup request. Is this actually mandatory? Do we need that? Like, is USB high speed yeah, but why is it in the protocol then? It's really weird. Is it just for testing hardware? That would be actually cool to trigger that to see how well our hardware is implemented. Let me investigate that a little bit more. So test flag is set here. Setup require high speeds. Yeah, it shouldn't be an issue actually with the 2 giga samples that I have available here. Yeah, might be really tight. Yeah. Oh, because we have set or enable one USB feature. USB set feature request. I think we can test that. That would be cool to see. We can copy that. Actually, we will do that. So I will add this to our code there. I think USB device status. Let's put it in here. Test flag, and what is still missing is deal. Okay, this is stuff. Fast speed endpoint init. Oh wait. Bus reset. Okay. That's high speed basically. Everything. We are resetting that stuff. Okay. But where is the eye diagram dealt? That was in a different. Okay, we have test mode deal. Where's this block? Token in. It's weird. Is USB high speed testing the quality of the transport? Sorry, you had me
To evaluate
interrupted.
USB.
You had me interrupted. Is the data? There is a standardized packet data. Is a test mode for USB high speed mandatory during the setup phase?
No. Test mode is only required for electrical compliance and signal integrity testing, not for normal device setup or enumeration.
Okay, so this is optional. All right. So let's we actually, I don't know how to you can trigger it. I think I will clone that. Under Linux, is there like an implementation for web USB? That would be interesting if you can just trigger with like an HTML. Okay, let's add the test mode up here somewhere. Device init. I will add the test mode here. What chat says. Okay, and I think it was here. Test mode, and that is where simulate CDC. test mode. Okay, so that's just txlen device address, txlen device address. It's before the break. It's right after the else case. Wait, there is no else case. Type request standard, and then there is a break. Standard, what break? Fucking hell. Okay, token in. No, we won't still be token in. Okay, so it's within this part here. So this is where it's doing its stuff. Whatever it does there. Alright, that would be that. Let's compile it. Meep. Errors, okay. What do you want? pbuff, test buff, undeclared. Oh yeah. We need to clone the definition of that one. I don't even know if it's ever... No, it's here. It's never... Test flag. Weird. It's right in the beginning of the device definition. Okay, CDC. High speed. Let's do it there. Test flag, and here is the test. Alrighty. Main CDC. Okay, that's a warning. Implicit declaration of fast speed. Oh, high speed. Should clone that. That's the main file. That's terrible. I should, like, the abstraction should be already done before that. Alright. Okay, that's also fast speed and what the heck is that here? USB buffer endpoint. We are already juggling the endpoints, the buffers here. We have like we made this circular whatever buffers. Okay, I guess we will do the same here. Endpoint TMA. Okay, that's called a different way. Endpoint. Is this RxDMA? Yeah, I believe so. Wait, no, right? Yeah, we didn't do much for receive, did we? We checked that. Process, yeah, that's USB write and read. Okay, And this is correct. This is Rx, whatever we receive. Alright. Yeah, we didn't rename that. So that will be high-speed device init. Init. There you go. P buffer. Okay. All right. I have no clue if that will work. We need to write the. That's so weird. Is it even plugged in? Okay, it's plugged in. Yeah, must be correct. Let's download it. And let's test it then. Yeah, it's exciting to see if we. But it won't work for sure. I will hear a ping bong bing, but it will not connect anything. Oh, why is the wire dangling there? Okay, there is a detached wire. Oh no! No! Ah. You remember how we soldered on the thin wires? Yeah, that wasn't good enough, apparently. I will show you with this camera. Ah. Yeah, this wire here is detached again. Yeah, that might be. That is actually not a bad idea. Flex PCB in between. Sandwich. Yeah, I need to reattach this one. I should have used tape to like keep it in place, because now I can't see stuff anymore. I should get some magnification glasses. Hey Ray. Should I solder again? I forgot which pin it was. I can't really see there. Okay, let me. Yes, this is USB. It won't be like super high speed, but it will be better. Hopefully. We can be still. It's not twisted or anything. Okay, I need, what do I need there? Untwisted. Yeah, this is actually, so how much tolerance do I have in length with high speed USB? It's not super speed, it's only high speed, so It's not like we need super fast, super length matched. Okay, I brought the super. What do you mean half a gig? Yeah, generally, I don't know, maybe we can do it. We have the time. It's just order flex PCB then. On a planetary scale, yeah. Which one is that? You're not helping, dudes and dudettes. You're not helpful here. I need information, and you give me flag. Okay, let me check the sheet again. Data sheet. I would need the microscope there, but I can move it. It's not mounted to the wall. Okay, I might be able to move over the microscope, but I can't. Everything is so high up there. This will be good. Okay, I think we can do it. Let me just get the footprint. Where is it? Pinouts. Okay, RCT6. What do we need? B. So it's 4 and 5. Pin 4 and 5 is what we need. .25 millimeters, and then it's like 20. That's like 1 millimeter then with high speed. 1 millimeter length difference. Do I see it right? Okay, I will move the microscope. This is like heavy, and it's with my camera. Oh no. Oh, fuck me. Oh, this is heavy. I don't even have space here. There are blades everywhere. Don't want to squish one. Okay. Oh. I will match it. I mean, we can match the length somewhat. I eyeballed it, so that should be fine. Let's get some light in here. Like that. I need to raise it even more, but it's so heavy. I don't have for the microscope, I don't have that much room here. Yeah, this is way too close. And also, I destroyed my new tweezers. I only have these ones. The other ones I dropped on the floor, and all the pins, all the like the tip bent, both sides. Terrible. there's no way I can do that. Oh, shit. This isn't even working. Voxel Boolean calibration, nice. Okay, I need to release that one here. Okay. Okay. Can I get it sharp? Nope. No, it's still not sharp. It's way too... Or do I tip the board over? Yeah. I can still tip the board. I need to be cautious. I don't want to destroy things here. Still not sharp. Why is it? Still too close. Why does it need to? I need a different lens here. This somewhat is like really needs a really high distance. I need to put something underneath there so it tips slightly over. Now the cables are in the way. Oh no. Now I completely detached it. I hope I can get this right. Yeah, no premium. I have no clue which one. Okay, should I length match them first? Okay, let's match the length. Should be really similar here. Yeah, there is a millimeter difference. Let's get this off. There should be now more or less same. Yeah, that we can do that. We can twist and then find out which one is which. And there are more or less. You know, the issue with that is that we need to order them, wait for them, whatever. It's like 2 weeks. We can't do shit in 2 weeks. I need a solution right now, and then we can figure out stuff later. Alright. fix more things. Oh, with the microscope it's so much better. Still. Dude, we can just botch it. It's the one connection. If it's bad, we can still fix it. Let's try this first. We always figure it out. It's certainly an option, but not for today. Yeah, that's a good thing. Okay, yeah, they're attached now. We can turn it on. Let's hope I didn't short anything. Okay. Let's try connecting USB. I don't hear anything. They get the right pads here. Don't hear anything yet. At least it should be giving off any sound. If there was USB going on. Maybe it's not initialized. Wait, let me do simulate CDC. Let's download that. Oh. The link isn't attached. Oh, where is the link though? Here. Okay. Yeah, I don't hear anything. Okay. That doesn't work. D plus, D minus. Hä? Oh shit. Something's. Oh, that's only. I heard. I heard some noises, but that was only the tissue. But this thing was shorting prints. I need to really be careful with this whole thing here. Also, this is an aluminium case on these power lines, and these power supplies are capable of doing really much harm. Loaf of soda. We are trying to switch to high-speed USB on our ultra cluster. Now what? Let me try. We were using. Last time. We check it. 3000 watts, yeah. High speed. Yeah, that's not working. Can't hear anything. I don't get anything on the USB, that's weird. Ground is connected, okay. Let me investigate it a little bit. Yeah, I don't see an issue there. That might be some extra debugging, my friends. Let me try to use. Okay, we can. Use our code and debug it with the. One thing at a time. Old firmware, it uses a different patch, different pins. That's the issue. Fast speed and high speed are using different pins on that. No, I don't think so. That's only for power. Let me check. Too many people shorted it. Yeah, let me download that. Apparently we have a connection there. RCC init, device init. Okay, here. Let's debug it though. See what happens. As soon as it I would expect it to config. No, I can't hear anything. I would hear the sound, at least. No, it's not. Give me a minute. It's very distracting. I don't think I even enable it. Where is it enabled? That's the RCC init. Okay, that's RCC init. Then there is device init. Enable.
Oh. It's delay. Oh, this is so annoying here. How the windows are organized. It's like, okay, we don't need that. Suspend control. Yeah, so that's what I think as well. As soon as the USB lines would be pulled in any direction, we would have an unrecognized device here. Yeah, it's not working. Both things are not working. I don't think it's the lines are swapped. We can swap the lines, but I don't feel it actually. It might be. We can try. I mean, it's worth a try. But we need to detach everything again before we short anything. It's the last thing that I will try. And then we will just postpone it to no, I switched the USB already. I'm not from yesterday. It's the German saying. Ich bin nicht von gestern. Tried our. Okay, that would be it. Oh, it's so much easier to solder with the microscope. Okay. That one made the sounds. This one didn't. This didn't do anything. Oh, we detached it while debugging. Okay, let's re-upload it. No, it was... No. Yeah, reversing. I don't know what's going on there. I can check if last time we messed around with the caps, but no, we had it running. I didn't touch anything except I pulled off one wire here. I don't think there's anything broken with that. Let me check. If the crystal was off, that would. Okay. I don't know. I need to debug that. Need to clean it up, detach the PCB from all the cables, and make a clean debug session. It's pin 4 and 5 in this direction, is it? Yes. USB. Oh no, this is wrong. Oh yeah. We are connected. Okay. Okay, we have pin 6 and 7. Okay. So my fault. 6 and 7. 6, 7. Okay. Yeah. How did I get this wrong? Yeah. Okay, that's 6 and that's 7. Okay, these two. Oh, take tweezers. Way easier than way. Yeah. Okay, that's 6 and 7. Okay, let's check it again. Doop, doop, doop. If that works, yeah, I looked up wrong. I mean, I looked it up, but at the wrong port. Still can't hear anything. Oh! I had something. Okay, I had something. What do we have? Device manager. But it was slow, so it means it's probably not detected properly. Yeah, unknown device. Now it's the question of device init. Now we will check if we get a breakpoint in here. Token in. Okay, let's try, or wait, not transfer. We just want interrupt. Okay, can remove that one. It does something. Else if setup. No. Reset. Suspend. Okay, nothing of those. Nothing of those. Ah, this is so annoying. Why is this so big, this window? We get a read message, okay. No, it might be, let's test if the wires are swapped. Okay. Let me turn it off again. swap the wires. That's done quickly, as we learned. I'll give you a nice view of that. Here. So I'll swap them. This will be the new 6. Oops. And this will be the new 7. 6, 7. Okay, there we go. Let's turn it on and see if that works better, huh? That doesn't sound like it works better. Didn't hear anything. I think it's badly soldered. Let me try again. I think the soldering, the connection isn't good. All that nice debugging technique and so on, it's all really difficult to do on stream because setup time and so on and so on. Have like hours and hours that I can spend here doing that, so usually I would do it offline. Okay, this shell should be good, this connection. Oh, why this one refused? Maybe it was shorted a little bit. Okay, let's try again. Nope. This doesn't work at all. Works? No, it was like really delayed. I don't think it's correct here. Yeah. It's not correct. Okay, the good news, we get a proper packet, it seems. If that effing thing doesn't annoy me. How do I remove it? Okay, it's the token out. Default break, okay. Switch token out. Oh, why is this fast speed token mask here? Endpoint mask. high speed token out. Okay, I need to check that. 30. It's all fast speeds, high speeds. Okay, I need to check that. That seems like it's wrong. That's fast speed, fast speed. Let me check the implementation here. No, that's not the right one. Where was this? Token out. Switch inst high speed. Oh, yeah, okay. But that should be the same. Yeah, it's the same. Endpoint mask. It's no different. And then it's switching endpoint 0 rx. Okay, let's download that. So the only thing right now is our code is not working. Oh, you know what? Now we can try this one here. That should be working. Yeah, that one is working. So yeah. Wait. Here. I think it might be 28 here. Yeah, it will be 28. Let me detach it so we can see it. Update already. Go on, update. No, okay, yeah, it was then 28. Okay, so code still doesn't work. Yeah, if you... Hey, loaf of soda. Which one? What is the... why is my chat not updated? Apparently I have some wrong setup here. Still. I need to compare it. But I think I'm done for today, or do you think we can still fix it? If I really clone this... Okay, let me do a last compare between my code and simulate CDC. At least the setup should be similar. Live link. More endpoints. Why is this there? We don't have it anywhere else. Oh, this is in token out. Okay, yeah, token out. Okay, let's debug it again and see where it messes up. Yeah, that's the question if I want to. So let's step down and see where we are failing right now. Can someone block this person? Dankeschön, thank you. What an idiot. Or it was a bot, or it was a bad code. In that case, I forgive. That's also high speed token mask, which 48 high speed. Okay. Switch 48. Yeah, okay, so this is the same. Then we end up in token out. So this is token out. Switch token out endpoint 0. Token on out endpoint 2. So there are only 2. It's none of both. What? I have wrong definition somewhere. That's alright. It feels like we should be not in transfer yet. Oh, here is one. That's the issue. We are switching the wrong tree. Okay, that might be one thing. That's certainly bad, because we are reading the flags and we are in the wrong tree for the interrupt. Yeah, but I still can't hear what's happening there. And also I wanted to change that to high speed here. Yeah, it failed again. High speed. Okay, let's try again. We have one less error. I should just replace this whole thing with this implementation that we have over there. Okay, let me debug it. Okay. Hey, DIY in the get. Oh, long time no see, my friend. How are you? Setup. That should be it. That should be it. 4? No, 20. What is 4? One. 4 is suspend. What? Okay. We are in suspend mode. Why ever it's suspended right now. We need to set up. Okay, so this is what we need. Setup. Oh, here we go. So this was we had like some issues maybe there. No, this whole thing is copied. That should be working. But now we are probably too late. Something's off here. Okay, we need a debugging tool to see where the error is. Okay, in worst case, I can just copy the whole interrupt, the other one, and do the same stuff. But I rather want to find out right now what's happening. Actually, maybe we can find USB debugging tool, Windows. Win debug, okay. Oh, that's debugger, I don't know. I think last time we had issues with what I'm working on. I'm trying to debug the high-speed USB that we added to the Ultra cluster. What's the name again? USB view, no, USB log view. Okay, here we go. I started USB log view, my friends. Let's start again. No, stop it. No. It doesn't even show up here. Yeah, unknown device. It doesn't even. Yeah, product ID too. Interesting. Yeah, no, it's not working. I really don't want to like clone the whole code, because there's a lot of crap in there. Okay, let's try it. No, that's wrong. Okay, let me try to copy the interrupt handler as it is. It might not be the issue though. Not sure. Wait, this is the wrong thing. Here. This is the one that I need to copy and then remove the stupid okay. Let's do an underscore here. Whoop. Here we go. Whoa, where does it start? UART, okay, there is one thing gone. UART timeout, baud rate, UART config, UART USB init, reset line coding. That's all crap, we don't need that. UART token. Okay, that's endpoint to data interrupt. Okay, we need to get that part. Get line coding. What else? UART para init. Okay, we don't need that. Okay, so we need only line coding part. It is USB, but it's an UART emulator. So this is get line coding, and we need, yeah, this is our implementation of that. So we replace that part. And this is one step after another. For now we didn't even have like code running. We need demonstrate code on the cluster first before we do anything else. Yeah. Case. Token out. Okay, so this is the switch. Oh. Token. Oh, endpoint 2. Endpoint 2. Endpoint 2. Okay. So this is what we do. Endpoint 2 token out. Endpoint 2 break. Okay. Here we go. Whoop. Does it compile? It looks like. Okay, it compiles.
It's recognized right away. No, it is working. Okay. So this way around it was easier. Apparently I had something wrong in the setup. Maybe some copy paste stuff. But I don't know if this is still working. Like we need like different buffer size and so on and so on. I need to assemble this. Code is working. At least this part, USB high speed. I don't know should we run a test? Oh wait, we have a test function for that. We might have a test function for the speed, the USB speed. But that's not representative because we are not using full buffer size. Still would be interesting to see serial test, speed test. Let's run it. Because it's doing something, but nobody knows if it's connect and test. Connect. Device has been lost. Preparing data flood. Okay, we lost the device. Okay, you know what? I will download the other CDC test. And then let's try to this one works. That's terrible. Okay. Effective baud rate. That's probably because it uses USB on the other side. I mean UART on the other side. But I'm breaking something. Why do we lose connection on this one? It's probably not fast enough or something, timeouting. Because I don't hear. Okay, let's try again. Device has been lost. DFGA, yes, it can. It's just this can be ignored. CDC ignores that part. This is just vibe coded. Why is no? That's not a problem because that works on. We can try. You know what? We can try the other example. I need to check the differences and especially when we receive data. Let me do the following. High speed. Line coding. UAP RX control. If we remove that,
You are just constantly serial port disconnected. What else do we do here? Wait, let me check the implementation of token out, line coding. Perhaps token out. I need to check if we are missing something here. Receive Rx control, receive top data, where top data. This isn't the issue here. What else do we have? CDC line coding. Let me check that. Token out 0 Rx len high speed type mask type standard request lens CDC set line coding. It sets the line coding. Okay. What do I miss? Maybe the heartbeat on interrupt 2 or something? I'm not sure. (200 milliseconds). Can I see in Event Manager what the issue was? Event log. Not sure. There is like this timer used, and let me check here. So what we have is timer 2. What is it for? Good night, DFT. Clear timer. That's timer. It's not. It's only doing timer stuff. Ah, that's not. No, that's UART stuff. Okay. Timer. It's apparently not doing it. Yeah, I know. The peripheral should do it. DMA init. Wait a second. That's UART. That's all UART. So that was actually for UART, the timer. Alright. RCC device. I have no clue what the issue is, why it's not responding. Why is the other one? You know what? We can do the following. We can use simulate CDC and do the following. We don't do anything on receive. Just ignore and see if the behavior is the same. I know there was like you need what is happening on USB again? Remain. Okay, that's T blah blah blah. Okay, let's remove that part. Oh, this is terrible. Okay, let's do this comment. This is the comments thing. Let's roll it here. Let's try that. That would be basically ignoring all incoming data, not processing anything. So that's Looney serial. Yeah, 2 megabytes per second. 23 megabits per second. Not sure if that can be made faster. Yeah, it's twice the speed, more or less. Twice the speed to full speed USB. That's still not like super fast. We are probably losing packets along the way with our dodgy wires there. "23 megabits is not good enough. We need 100 or 200 megabits at least." What's the packet size? Let me check that. Okay, I think. Wait, total bytes. Where is it sending? How is it sending? Port, await, writer, write, packet. Packet, EU, packet size 124. Is not actually this. Let's try 512. Yeah, I can do that. Yeah, that's not changing anything. Wait, they connect? Yeah. That's not changing anything. High speed USB. In the end, it could be the peripheral that's not capable of doing anything faster than that. Who knows? This MCU is running at. Oh, wait a second. What speed is it running? Let me check system. 90. So this is external. One. Let's try that. That doesn't work. Do we need like to change the... No, we shouldn't be needing to change anything there because it's only pulling... Where is it? The clock setup. No, that's not it. Where's the RCC clock? There it is. Diff 4. Why are we at diff 4? 96 diff 6. 124. No, it doesn't do it. Yeah. No, if it's even running. That wouldn't make sense because we are using the 3 times the speed of or it's not booting at the Flex PCB to basically as to sandwich the new MCU for the new pins that we use for the USB. Also programming pins could be done like that, but it will be hard to solder. I don't know. If I would do a Flex PCB, then I would like just do one that attaches this side of the MCU. Yeah, no, I don't think I will use them. Yeah, I think I will use completely different MCU then. Yeah, that doesn't work. I don't know why. Can we do that though? We can try all the things. Yeah, no. Only 96 works here. Yeah. What with 120? Okay, 120 megahertz works, it seems. I don't know why it doesn't work. 120 megahertz works, but it's not faster, it's rather slower. Weird. You know what? I'm wondering what happens if I like twist the cable, if it's getting faster or whatever. Yeah, I guess so. Let me twist the cable. It is. Oh, that's even slower. I don't know. Yeah, I might lose more packets. That's okay. Interesting. Interesting theory. Okay, if I lose packets, if it's faster, so let's try to clock it weirdly slow and then see what happens then. I don't think it will. it will work better. No, it's the same. Same. Let's try 48 megahertz. I don't know if the clock is not stable enough for 144. It's weird. Yeah, same. Nothing changes here. 96. Also good. I mean, a little bit headroom there. The only thing we can do is optimize, especially for transfer speeds. But how? How would you do that? Yeah. No buffer copying here. We're not even looking in the buffer. Buffer is just filled and we ignore everything and return. The peripheral is returning instantly, I think. What does it do? We can check. Here it is. Where do we? Okay, so the only thing we can speed up is basically switching stuff like that. Case token interrupts. We can do a faster switch here or something, but this is like only a few clocks or whatever. It might for 512 bytes each. Yeah, it okay, well, let's see. So, times 8. This is what we actually received when we tested it. So we are already like 4 times faster, but or 3 times faster. Okay, DMA double buffering mixing packet size 512. Yeah. You know what? I'm happy what we have right now. I will check if I can tweak it a little bit. It seems we can achieve like tenfold more. So the issue is somewhere else. If we can log what interrupts it's doing all the time. So if we only just like bulk transfer no, constantly the days where I'm not in the mood, that happens every week. How do I fight with it? I don't work. But then I have I feel bad about it. Anyways, peeps, I think this should be it for today. We can optimize that. I will try to find the issues that we have, the losing connection on the other project or the other firmware. Fix that, optimize the bulk transfer. Coffee. I take a nap. Nap is always great. Yeah, but we're using crystal. I don't know. "12 megabits. Yeah, but we are higher than that, so it's not falling back. We are always higher than the 12. Final bite, Gemini copy paste file. Yeah, let's call it a day, peeps. We were somewhat successful. I don't know. At least soldering through the microscope here, the new setup is nice. There is a list of recommendations. Okay. Yeah, I will check it out, Terran. So you just asked AI and they give me the list? Anyways, pips. I'm happy with any progress. Achieving the high speed. Yeah. Okay. I will check it out. Thank you very much. See you, everyone. I think next Wednesday is the next stream. If there will be a surprise stream, then it will be so. But I think I need to do also some home improvements here. Bye bye, everyone.